Bismillahirrahmanirrahim. You were doing question number 2. So in the previous lecture I left it here. Now we made two binary relations. The first one was R1. I have written the domain and range of that. Now the second binary relation is this. In order to write its domain, again what we are going to do is we are going to pick the first element from each ordered pair and going to make a set of it, and range of R2 will be 1, just 1, because only 1 is used as the second element of the ordered pairs. Okay, so this completes question number 2. Now moving to the next question. Now the next question that we should try is question number 4. First, question number 3 is easy to attempt. They are asking you to find two binary relations in these sets. L is given to you, M is given to you. So you have to find L cross L, L cross M, and M cross M, and then write just two binary relations in that. This is easy to attempt. Now coming to question number 4. They are saying that if set M has 5 elements. So you have a set which has 5 elements. Name of the set is M. Then find the number of binary relation in M. You have to find the number of binary relation. Okay, you don't have to find all the binary relation. You just have to tell them how many binary relation is possible in M. So it's quite easy. Just question number 3. They are saying that the number of elements in a set is 5, and you have to find number of binary relations in M is how much. You just have to tell them the number of binary relation. Okay, you don't have to make all of them. So we know that if the set M has 5 elements, then M cross M, the number of elements in this, okay, number of elements in M cross M will be 5 into 5, because in M we are using M as both the first set and the second set. The Cartesian product of M will contain 25 elements, and the number of binary relation, we know that is number of binary relation is actually the subset of this set. So number of binary relations will be binary relation will be 2 raised to power 25. This is the number of binary relation that you are going to obtain when you make all the possible subsets of this set. Okay, so this is how you do this question. This completes question number 3. Now moving sorry, not 3, 4. This is question number 4, and now let me do question number 5. So question number 5, it is given that, let me read it first. Over here, if L is equal to X such that X is an element of natural number, so it means L has natural numbers. Okay, X here is representing the elements of this set, and X is defined as, here the description of X. X belongs to a set of natural numbers. It means this set contains a set of natural numbers and not all of them. Over here we have a restriction that X is either less than or equal to 5. So we are going to write all those natural numbers which are either less than or equal to 5. It means we won't go for the natural numbers which are greater than 5. Now M is defined as Y such that Y is an element of prime numbers and Y is less than 10. So here you have to write all the prime numbers which are less than 10. Then make the following relations from L to M. You will take L as this, M as this set, and we have to make the relations which satisfy these conditions. The conditions are given to us. Okay, so we are going to write only those binary relations which will satisfy these condition which is given to us in this question. So let me find the set L and M first. Okay, so it is given that set L is X such that X is an element of natural numbers and X is less than equal to 5. This is set L, and if I write it numerically, this set will be, it contains natural numbers which are less than or equal to 5. Then obviously it will contain 1, 2, because 2 is also less than 5, 3 is also less than 5, 4 is also less than 5, and this equality indicates that x can be equal to 5. Okay, but it can't be greater than 5 because we are taking x as less than or equal to 5. Either it is equal to 5 or less than 5. We know that after 5 we get natural numbers which are greater than 5. So this will be the set L according to the given condition. Set M is y such that y is an element of prime number and y is less than 10. So we have to write all those prime numbers which are less than 10. You know that 1 is not a prime number because a prime number has two factors, 1 and the number itself, but we know that 1 is a number which has only one factor. For this reason it is not included in the set of prime numbers. The set of primes less than 10 will include 2 because it has two factors, 1 and 2. It will include 3 because it has two factors, 1 and 3. It won't include 4 because it has more than two factors, and it will include 5 because it has two factors, 1 and 5. Again, 6 will not be included, 7 will be included, 9 will not be included because it has more than two factors. Okay, 10 will not be included. Sorry, we have to write less than 10, so we don't need to go further. So the only elements which satisfy the condition given to us for M is 2, 3, 5 and 7. Now we have to find the binary relations in from L to M. Okay, so it means that we have to find L cross M because we are going from L to M. Binary relations from L to M means we have to take L as first element and M as second element. So L will be L is 1, 2, 3, 4 and 5 cross M is 2, 3, 5 and 7. In order to find L cross M, I am going to make all possible ordered pairs from L to M, and 1, it will include 1, 2, 1, 3, 1, 5, 1, 7. Again, I'm going to take 2 and then make all its possible ordered pairs with these elements. Okay, so it will contain 2, 2, 2, 3, 2, 5 and let me write it here, 2, 7. Now pick 3 and 3, 2, 3, 3, 3, 5 and 3, 7. Now similarly pick 4, 4, 2, 4, 3, 4, 5 and 4, 7. Okay, okay. 3, 2, 3, 3, 3, 5, 3, 7, 4, 2, 4, 3, 4, 5, 4, 7. Okay, now pick 5 and make its ordered pair with set M. 5, 2, 5, 3, 5, 5 and 5, 7. Okay, this will complete the set. How many are there? 1, 2, 3, 4, 5, 6, 7, 8 and 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So number of ordered pairs that we have is 20, and it should be how much? 5 elements we have here and 4 here, so it means that it is correct. Okay, so we have made 20 and all possible ordered pairs were 20. Now coming to the first part, it is written that the question is you have to find a binary relation R1 which is defined as it contains xy, means ordered pairs. Obviously we have the symbol of an ordered pair here because we know the binary relations has elements in the form of ordered pairs, such that y is less than x. So you have to take all those ordered pairs where y is less than x, means y is here indicating the second element of the ordered pairs in the binary relation. So the second element should be less than x. You have to write a binary relation which is satisfying this condition. Okay, so you are going to have focus on this condition, that y should not be greater than x. You are going to take all those ordered pairs where y is less than x. Then you will be defining R1. So we know that R1 is a binary relation from L to M. That's why its elements are going to come from this set. So what am I going, in order to form this binary relation, what am I going to do is I'm going to pick those ordered pairs where y is less than x. Okay, over here 1 2 is not our choice because here y is greater than x. Okay, y is the second element, x is the first element according to this definition. So the second element should be less than the first. Here 2 is greater than 1. The second element is which is used in this ordered pair is 2. It is greater than 1. It means that it does not satisfy this condition, this one. Okay, here also this also does not satisfy. 1 5 is not satisfying. 1 7 is not satisfying. 2 2 is also not satisfying because 2 is not 2 is not less than 2. Okay, we need to find those ordered pairs where this second element will be less than the first element. Okay, 2 3 is not our choice. 2 5 is not our choice. 2 7 is also not our choice because over here 7 is greater than 2, not less than 2. We need y less than x. Okay, now coming to 3 2, over here the y, the second element is less than 3, so y is less than x. So it means that this satisfies, this ordered pair satisfies this condition, so I'm going to pick this one. Okay, again 3 3 is not satisfying. Over here y is not less than x, this is not less than x. Now coming to 4 2, here y is less than x. Okay, so this ordered pair will be included. Now over here again y is less than x, so 4 3 will also be included because y is less than x. 3 is less than 4. Okay, here this will not be included because here y is greater than x. Here y is again greater than x. Over here y is taken as 2 and x is taken as 5. So over here again we have this condition satisfied. So this ordered pair will be included. This is also going to be included. Okay, this again the remaining does not satisfy this condition, so I'm not going to write it. So we have a binary relation which is satisfying this equation. In the question it is asked that you also have to write the domain. If you see at the question again, you have to find all these binary relations and you have to write down the domain and range of each relation. So after writing the relation, I'm going to write the domain and range also, which is very easy. Domain of this R1 will be the set of the first elements that are used to form this binary relation. We know that 3 numbers are used, 3 4. Don't write 4 again because you know that a set contains distinct elements and domain and ranges are sets. Okay, so I'm going to write 4 just once. I'm not going to write it again for this. And again 5, these are the 3 elements which are used in the first for the first element. So this is the domain of set R, a binary relation R, and range of binary relation R1 will be the set of elements, the second elements, okay, which are 2 3 and that's all. Okay, so these are the domain and range. So this is the first part. Similarly, now going to the next part. Second part, we are given that R2 contains all those ordered pairs such that y is equal to x. So we have to pick those ordered pairs where x and y are equal. So easy. Over here 1 5, and here we had 1 7. Now I have to pick all those ordered pairs where x and y are equal. So R2 will be 1 2 is not satisfying this condition because x and y are not equal. They are equal in this ordered pair 2 2. Then again this won't satisfy, this won't satisfy, and the next ordered pair that will satisfy is this one because x and y are equal, both are 3. Okay, and similarly moving in the same way 4 5 5. Okay, we have 5 5 5 and 5. That's all. Okay, these are the ordered pairs which is satisfying this condition. So again, finding the domain of R2, we will need the first element of the relation, which is 2 3 and 5, and range of R2 is between 2 3 and 5. Okay, again we have 2 3 and 5. The same numbers are used as range and domain, therefore they are equal. Okay, otherwise this not normally happens. Okay, so this is R2. We have taken all those ordered pairs in which x and y are equal. As you may see here, we have written the domain and range. So this completes part 2. Now let's move to the next part. The next part is you have to write R3. It is given that it contains those ordered pairs such that x plus y is equal to 6. It means that you have to choose those ordered pairs in which the sum of the first and second element is 6. Okay, so this will contain those ordered pairs whose first and elements add up to give 6. We know that 1 plus 2 is 3, not 6. So we are not going to use this ordered pair for this. 1 plus 3 is not 6. 1 plus 5 is 6. So I'm going to add this ordered pair to this relation because this is the condition which is satisfied by the ordered pairs which are contained in R3. 1 plus 7, this does not satisfy. 2 plus 2 is not 6. 2 plus 3 is not 6. 2 plus 5 is not 6. Similarly, this is not 6. This is not 6. The next ordered pair that satisfies the given condition is 3 and 3 because 3 plus 3 is 6. Same here, 4 and 2 is the next ordered pair where 4 plus 2 is 6. So I'm going to take this one. 4 plus 3 is not 6. 4 plus 5 is not 6. 4 plus 7 is not 6. 5 plus 2 is not 6. 5 plus 3 and this and these are not 6. Okay, so this is the these are the ordered pairs which satisfy R3, and domain of R3 will be the set containing the first element 1 3 and 4, and range of R3 will be the set containing the second elements. Okay, so the second elements are 5 3 and 2. So 5 and 3 and 2. Okay, the order does not matter. You can write 2 3 5 as well as 5 3 2 in set. The order does not matter, while in the binary in the ordered pair it does matter. Okay, 4 2 is not equal to 2 4, but over here we can just arrange them again and write is a 2 3 4. It won't change the meaning of the set. So this is third part. So we have written all those ordered pairs which satisfies this condition, and after writing the binary relation, we have written as domain and range in the usual way. Okay, now moving to the next part. Part 4, and this is the last question of this lecture. We have to write x y such that y minus x is equal to 2. So in this case we have to take those ordered pairs in which when we subtract the second element the first element from the second element, we are going to get 2. Okay, now let me check if this ordered pair belongs to R4 or not. Now we know that y minus x is not equal to 2 because 2 minus 1 is 1, not 2. So this does not satisfy. 3 minus 1 is 2, so it is satisfying this condition. 3 is the y element, 1 is the x element. Okay, so 3 minus 1 is 2. So it means that this ordered pair satisfies this condition. 5 minus 1 is not equal to 2, 7 minus 1 is not 2, 2 minus 2 is 0, 3 minus 2 is 1, 5 minus 2 is 3, 7 minus 2 is 5, 2 minus 3 is negative 1, 3 minus 3 is 0, 5 minus 3 is 2. This is the ordered pair which is satisfying this condition, because y over here is 5, x is 3. So 5 minus 3, y minus x, this is equal to 2. So I'm going to pick this ordered pair and write it in R4. 7 minus 3 is not 2, 2 minus 4 is not 2 because it is negative 2. Okay, so be careful about this one. 3 minus 4 is negative 1. 5 minus 4 is 1, 7 minus 4 is 3, 2 minus 5 is negative 3, 3 minus 5 is not equal to 2. Be careful about that, because 3 minus 5 is negative 2. Yeah, when we subtract it, it is negative 2, not 2. Okay, so I'm not going to take this. 5 minus 5 is 0, 7 minus 5 is 2. This one is 2, so I'm going to pick this ordered pair and put it in the set of R4, because it does satisfy this condition. Okay, so you just have to see which ordered pair satisfy the condition which is given in these relations, and domain, then write the domain of R4 is equal to, domain will be 1, 3 and 5, 1, 3 and 5, and range will be the second element 3, 5 and 7. Okay. 3, 5 and 7. So this is the domain, and this is the range, and this is the binary relation. This completes this lecture. The next question, for the next question, I'm going to start a new topic, that is functions. Okay, in the next lecture we are going to do function, and then I'm going to do question number 6 of this exercise. And this completes the lecture for today.